So, good morning. My name is Murakoshi. I'm in charge of the production network at Yahoo Japan. I would like to talk about the outline of the company and recent efforts on our infrastructures. This is the agenda for today. I will introduce our recent efforts to improve our network. Then I want to focus on OCP Backpack and talk about it in detail. First, let me tell you a little bit about us. Yahoo Japan was established in 1996 and has a history of more than 20 years. The headquarters is in Tokyo. We also have several offices across Japan and more than 6,000 employees. Yahoo Japan provides more than 100 web services through our portal site and offers about 50 apps each for iOS and Android. Popular services are news, weather, auctions, shoppings, transfer guide, and so on. Our revenue grows for 20 years since the launch of services. It reached 853 billion yen in 2016. And total monthly PV is over 75 billion. Yahoo Japan is the top portal site in Japan. Yahoo has been migrating our services from PC to smartphone. We adapted the rapid shift of users to smartphone successfully. In the future, we are aiming to improve customer satisfaction by utilizing user data. Let me give you an example of our latest data-driven services. In Tokyo, people take trains to work. Many trains are packed in the morning, so Yahoo Japan offers a train transfer guide application. You can get train the route, the arrival time, and how much it costs. The screenshot on the right is an example of search result of transfer guide. Recently, we added a new feature to the app called Unusual Congestion Forecast. It predicts the congestion level of trains and stations by using AI or machine learning and big data. The picture on the left shows the congestion level around Tokyo Station on the map. By using the congestion level data, Twitter posts, and search routes on Transfer Guide app, we will predict when and where abnormal congestion could occur. It provides further convenience to users by proposing alternative routes to avoid the congestion. So as I explained with the slides so far, Yahoo Japan provides various services to a large number of user base. To ensure the stable operation and adapt the rapid growth, we need a robust infrastructure. Now I will talk about our network infrastructure, which I am in charge of. Main components of Yahoo Japan's network infrastructure are CDN, backbone network, and data center network. We design and operate all of them internally. Our geographic coverage is only Japan. So our infrastructure is not as big as Facebook, but it's much larger than typical enterprises. Let me give you an idea on the scale of our infrastructure by sharing some numbers. We are managing 80,000 servers and 8,000 switches. My team is responsible for the entire network, but has only 35 members to cover design and operation. Here is a brief description of CDN and backbone. Yahoo has more than 6 data centers and assign separate BGP AS numbers in Eastern and Western Japan. Transit to Internet are located in Tokyo and Osaka, and CDN is deployed there as well. Also, there is a data center in the United States. Traffic to and from Internet, so-called north-south traffic, has been increasing as rich contents like video news, video streaming are getting popular. We address it by scaling up network infrastructure so far. Next, I will address the data center network. We still have some legacy network with traditional architecture. The diagram is an example of network configuration. You can see traditional core configuration on the left side. On the other hand, we adapted cross network in some parts. However, due to technical issues, we have not deployed it widely yet. I'll explain the reason later. In our internal network, so-called east-west traffic is rapidly growing as a result of distributed processing such as Hadoop. In fact, the size of internal traffic is already tens of times more than the external traffic. So in order to keep up with the growth of internal traffic, we are trying to migrate to cross network, because cross network is much better optimized for it. To design and build a new cross network is not difficult. Simply deploy it and deliver to service and application team. The problem is replacement of existing networks. The existing networks tied to various services. In some cases, service team does not want to change IP address, for example. So to be honest, we are still having hard time to replace old networks. We like to migrate to cross network quickly, but it takes time. Now I will move on to talk about our recent efforts. I just explained our internal net traffic is rapidly increasing. When we plan to tackle the issue, we thought that the hyperscaler like Facebook should have the same issue. The chart was published by Facebook. As you see, their internal traffic is growing very rapidly. So we decided to leverage expertise and knowledge from Facebook to consider our infrastructure strategy. That is the reason why we support OCP. This is a table comparing our data center network stack with hyperscale. We have successfully adapted hyperscale initiatives into our strategy. The slide shows only Facebook. For this session, I focus on network design and OCP backpack, but we also internally develop operation tools for automation. In order to cover both old and new equipment, we have been writing the code to develop tools by ourselves. Just recently, we decided to adopt App Store for cross-network to reduce the number of software engineers and development time. In design part, as I explained, we are trying to migrate to cross-network as much as we can. There was one big problem. The issue was SLs. We manage security among internal services by SLs. In the traditional network, a large number of SLs are configured at the L2 and L3 border of core switches. Therefore, we deployed a cross network only as a single security zone. Here is a diagram showing how many SLs we have. It shows the growth of the number of SLs configured in core switches from 2 years ago. Each line represents the number of SLs configured in each core switch. The maximum number is 110,000 lines on the brown line, and it has doubled since 2 years ago. The operation of SLs are automated, but it is clearly reaching to the limit. We needed to distribute SLs. In fact, we starting facing unknown bugs and unstable control packet due to CPU high load during configuration. As a result of consideration, we decided to distribute SLs to the servers. So we have internally developed a system to move security function to servers while keeping the existing security policy. It is under final testing, and it is almost done. By using this system, we can migrate our network design entirely to cross-network. Next, backpack. Why we are interested in backpack. Regarding the OS, we chose Cumulus Linux as network OS for white box because we don't have enough engineering resources to develop our own network OS like Facebook FBOSS. In fact, we are using Cumulus with white box switches in our production network before Backpack was announced. We purchased backpacks and installed in our Tokyo data center. This is a picture when backpacks were delivered to the data center. It may be too small to see, but the serial number is 1 and 2. So I was interested enough to get the hands on the world's first 2 units. As you may know, cross-network requires use of shared switches or 3 tiers of box switches to deploy at large scale. So we analyzed the pros and cons of 3-tier configuration of box switches and shared switches. The advantage of the shared is the high port density. It means that the cost of cables and optics can be reduced. On the other hand, if the sub fails, the impact is much bigger. If you try to do sub redundancy, it becomes complex and causes other issues. Above all, the upgrade takes a long time. It could take several hours long. In a 3-layered structure using box switches, the upgrade of each switch takes much less time. There is no single point of failure, and the configuration is simplified. Instead, you need a lot of lax cables and optics. We have chosen charge switch in order to reduce OPEX and CAPEX relating to the cables and optics. Then backpack is now available. The area circled in green is backpack. Backpack can take advantage of both box switch configuration and charge switch. I think it can reduce CAPEX and OPEX significantly. The bottom is a network diagram replacing 2 layers of spine switches with backpack. The diagram above explains the logical network configuration inside each backpack. Cumulus Linux is running on all of line cards and fabrics and configure a small cross network inside. Here is a screenshot of console which logged into a red line card of backpack LC1L. So it shows routing tables. These addresses represent loopback addresses for other line cards and advertised via fabric cards. Finally, I'd like to share some test results of backpack. We usually run detailed tests in our lab before introducing new hardware into our network. This time we tested backpack using several switches, servers, and measuring instruments XZER. You can see the detailed test result in this URL. But unfortunately, it is written in Japanese. Sorry. The underlay is configured with 2 backpacks and 2 leaf switches with BGP. Inside network of backpack was configured with iBGP. Fabric was configured as route reflector. We use a feature called BGP unnumbered of Cumulus Linux. I like the feature very much because it simplifies the configuration of BGP greatly. Overlay was configured with EVPN and VXLAN. However, I have no plans to use the EVPN in our network yet, so it was purely evaluation purpose. We tested both VTEP on leaf switch and VTEP on backpacks line cards. Here is the summary of our test result. As you can see, all tests were passed. We validated BGP EVPN single home and dual home features, behaviors, as well as check packet itself by packet capture. Additionally, we tried RFC2544 performance measurement by XZER packet generator. I don't explain it in detail in this session, but I can tell you backpack passed the whole test without problem. Finally, I will explain our future plans. We are planning to construct cross network with backpack as an analytic infrastructure for our data science team to create new service with our big data this summer. We will continue to advance our network infrastructure to support the company's initiative for data-driven services and hope to share progress with you again in the future. That's all. Thank you very much for your attention.
Thank you, Kenya. It's always good to hear about actual use cases of OCP equipment. We have time for some questions. In consideration of the language, we do have someone who can translate, but if you could also ask your questions slowly, we may not have to use that. So go ahead and use this mic here, or raise your hand and I will come around.
Oh, sure.
You mentioned about 10,000 ACLs, and you managed to push all of them to the servers, and with this particular architecture, you no longer need any ACLs on the switches?
わかりました。11万のアクルがあって、ホストサイドに持っていったことで、もうそのアクルを足していくことはなくなったっていうことで合ってますか？
いや、これからそのシステムを入れるので、これからですね。まだ今運用してますっていう。
So yeah, we are going to migrate ACLs to the host side from now on. So we will see how much we can reduce from now on.
Other questions?
No.
Just to follow up on that, so what do you think about the ACLs on this particular switch? The backpack.
バックパックのアクルに対する対応性能というか、そのあたりに対する意見はありますか？
いや、バックパックには入れてないんですよね。We didn't deploy ACL at the backpack.
Okay.
So we don't use ACL in a backpack. We use ACL in the host side so that backpack wouldn't have any ACL there.
So you guys have no comments on the capabilities of ACLs and
バックパックのアクルに対する性能に対する何の見解もないということですよね。
そうですね。そこはあんまり期待してないです。
We don't have any perspective on that yet.
It seems like your network is mostly a legacy managed network. Can you comment on the network-wide control SDN aspects of controlling all of these switches, each of which has its own copy of the control plane?
So the question has to do with managing the backpack, and that the backpack is basically composed of 12 individual control plane or CPUs. How do you manage that?
バックパックは中身は実際には12個の個別のスイッチで出来上がっていると思うんですけど、それらを運用していくところに対する課題とか出てきそうでしょうか？
それはアンシブルとかそういうものを使って一律に運用しようとしています。
We don't see any big problem to manage backpack because we use software like Ansible to manage and operate those individual switches.
Automation tools, yeah, Ansible.
I was just curious if you could comment why you picked Backpack for this as opposed to one of the commercial switches.
なぜ商用のスイッチでは、OEM から出てるスイッチじゃなくてバックパックを選んだのかっていうところについてコメントいただけますか？
Before you answer that, could you identify yourself?
Oh, Craig Matsumoto with 451 Research.
もう細かいですか？
バックパックを選んだ理由っていう中に他にもコマーシャルで写真のスイッチいっぱいあると思うんですけど、特にバックパックを選んだ理由っていうところをもう一度教えてもらえますかって話ですね。
このさっき言ったプロズ&コンズで、ここでOPEXも CAPEX も削れると思ったからなんですね。
So I think going back to this slide, that traditional chassis switch has cons of sort of large overhead of upgrading and also the bigger failure domain. And traditional, bulk switch needed more, optics and cables. But what Backpack allowed was there are actually inside of the switches individually, sort of 12 switches just running as a chassis switch, and they can also, minimize the grading time and also minimize the failure domain. As well, they could also save a large number of optics and cables.
Do you have an estimate for the capex you saved?
何らか従来に比べてキャペックスをどれだけセーブできるとか、オペックスをどれだけセーブできるかっていう見解はありますか？
キャペックスの部分だとやっぱ光のインターフェースが安くなるんで、その分は何分の1とかになると思ってますっていうところですね。
例えば何分の1と3分の1とか4分の1とか。
4分の1ぐらいですかね。
So I think a large portion in terms of capex wise would be optics. So he's saying his instant number that he can share with you is about a quarter of the cost is something that he can he'll be so basically 75% cost is kind of saved relative to the traditional chassis switch.
Okay, thanks.
Yeah, Mark Kühner, SAP. You mentioned that you introduced Apstra in your management layer. Question, what do you do with Apstra from the layer perspective, and what is your experience?
So the question is, what does Yahoo Japan use Apstra for, and sort of initial feedback on experience? Apstra の具体的な用途と、実際使ってみてのところの感触というのを教えてもらえますか？
そうですね。アプストラさんを使ってみると、やっぱ設定とかがすごい、一瞬でできるんで、自分たちの意図したもので設定ができて、かつ自分たちとしては開発の工数も削減できるんで、すごい助かってます。ただまだ今入れたばっかりでっていうのと、このバックパックにはアプストラさんを入れてるわけじゃないので、違うベンダーさんのやつを入れてるんで、まだ、そのコストが削減できたっていうところが、一番いいかなというところですかね。
So basically, the Apstra is for the use of the configuration of the switches. So configuration of that is quite automated already, so that they save a lot of time to spend, design and configure and also review the configuration of each switches. But in this stage, they haven't implemented Apstra for backpack particularly yet. Apstra is for other switches there, yeah. So in terms of the scalability from the corporate wide-wise, they will see how much they can also have more efficiency around.
Okay, I know there are more questions. All right, go ahead.
Thank you. Usually when using multiple chassis to implement a closed network, you have unique AS numbers. How do you manage that when using backpack chassis?
You need more AS numbers, right? Yeah. バックパックをシャチ型で入れていくとなると AS ナンバー、たくさん使っていくことになると思うんですけど、そのあたりに対する見解、もしくはアプローチっていうのはどういうふうにしてるんですかっていう話ですね。
AS ナンバー、そうですね、そこ、Facebook さんとかみたいにそこまで大きな、ディプロイがあるわけじゃないので、今はまだその2バイト AS で足りるぐらいの予定ですっていうのと、あと拠点ごとに閉じた感じで作ってるんで、まだそこまで BGP の AS ナンバーが足りないってことはないです。
So in terms of the AS number wise, not unlike Facebook, we are not at that scale yet. We are implementing closed network by region, so that we still have enough number in double digits number of AS. So we don't see that scalability problem yet. That's staying.
So I know there are more questions. You can catch Kenya afterwards, but we do have to close this session. Let's thank Kenya for his talk today.
Thank you very much.